In this episode, what I want to do is look at Python and how to manipulate files. I'm using PyCharm 2019.1. In this particular example that I have written here, we'll go through a bit of the code. First of all, I'm importing the libraries SciPy. It's a scientific library, and I'm importing the miscellaneous component of it, as well as I'm importing the operating system, the OS library, which is for the, in this case, I'm running on a Linux operating system, which is Ubuntu 18 dot something or other. In here you'll see I'm setting up the variables. Exceptions I'm setting to 0 because I'm dealing with a in case of any exceptions that are dealing with, I want to count how many exceptions I am getting. I give a ridiculously large number for the minimum, and I'm setting x to -1 because I'm going to be using a counter, and I want to make sure x is 0 on the counter, and a time multiplier which is set to 1 by default. That it means that, for example, 1 minute could be 1 hour. It's the number of pictures I'm taking. In this case, I'm taking 1 picture per minute, so I want the time multiplier to reflect that. I'm setting up dictionaries. In here we have 3 dictionaries I've defined. I find that 80 to 90% of the time I'm using dictionaries over tuples or arrays or lists. A dictionary in this case is a key that is separated from its values by a colon. The items are separated by columns, and the whole thing is enclosed by curly braces. These, in this case, these are empty dictionaries, just curly brackets. It's important to know that keys are unique within a dictionary, while values may not be. I've also created a one-dimensional array called RBG, and I'm setting this one-dimensional array to 3 columns. I'm setting up locations. Here, imaging area is the location where the images are located, and the CSV underscore file is the location and file name for the CSV file that I'm going to create. As you can see here, I have the file name, file underscore name, in the operating system list directory imaging area, and I'm going to try and find and process JPG file. Note that I'm setting it to .lower. So what this says is F file name, the last 4 characters right end of the file name, .jpg, 4, 1, 2, 3, 4, lowercase, because in Linux, of course, you could have upper and lowercase, so I'm setting everything to lowercase. If this file name is lowercase .jpg, then I know that it is a graphical file. This could be a PNG file, a GIF file, a TIFF file, whatever you want it to be, as long as it's an image. An MOV file, a movie file, or an MP4 is not a image, so you have to be an image. I'm going to add 1 to X. Recall earlier that x is equal to -1, so now I've set it to 0. My array is 0, 1, 2. 0, 1, 2 is a 3-dimensional array, or a 3-column array. So I'm going to determine the name of the file identification without the extension. So here I am looking for the base, which is the file name, and the base is set everything left of the period. I'm going to split the text so that the base 0 is actually going to be everything left of the period, and I'm going to give it a file number. You see, what I want to do is I want to number them 0, 1, 2, 3, 4, 5. In my case, you could see in the run here in Spicy, I got G03042. Well, 03042 with a G in front of it is not an integer value. It's not a number. It's a character. And as a result of it being a character string, it's not in sequential order. So what I'm looking for is I'm searching for the minimum file number. If you recall, I had a crazy large number for minimum, and I'm going to look for 3042, for example, or 00000. I'm going to look for the minimum number. This will allow me to manipulate the data later. I'm going to also calculate the red, green, and blue values of the image using this sci-fi mean axis 0, 1 configuration. I'm going to then associate the file name with the value of x. So file name 0, that's in my dictionary. File name is my dictionary. I am going to give it RGB x, 0 is going to get RGB 0, 1, 2, and the third one is going to be a sum of the red, green, and blue values. This is the value, a gray value set in the imaging process. Once I do that, I'm going to print x 0, 1, 2, 3, 4, the file name, the red, green, and blue values, as well as the gray value. I'm going to look for an exception if, for example, this calculation fails for some strange reason. I want to get an exception. So I'm going to add exceptions, and because it is an exception, I have to subtract 1 from x to deal with the placement values. Once I've done that, I'm writing the file. First of all, I write the time, file name, red, green, blue, and value. Those are my headers. And then I'm going to write out for I, all the way up to the maximum of x, the time, the file name, the colors, and I'm writing it to my write file. When it's done, I'm going to print done with the total number of exceptions equaling the total count of exceptions. And then I close the file. The result of that is shown here. And if I slide all the way down, you will find that I'm done with the total number of exceptions equaling 0. That's very good. So I've generated a file. This file allows me to process the red, green, blue, and grayscale using R. What if I want to take these values and put them into one column? How would I proceed to do that? Well, I could rewrite this and have it print out in one column, but it's time consuming to run this analysis. It takes about 1 second per image to run, and as you can see, I got 3,394 images. The question I have is there a better way? I created a file called read files. Kind of a meaningless name. It reads files. So let's look at it. You will see that I import the library CSV. I do have a dictionary called classification, and it's in the empty set. Needed that for defining. I have a number of variables defined. K equals 0, which is an identification marker of the time and file name. I equals -1, which is the rows to be processed. Again, I set -1 so that it'll set to 0 through my iterations. N equals 1 is the row being processed. X is the spectral color, and J is the spectral intensity. Definitions. Well, my time label is the classification 0. My file label is classification 1. And how that plays out is that if this is my time, it's going to say time up here, file name, red, green, blue, value. I have to deal with the time label and the file label, and the time label is the classification 0. The file label is classification 1. And then from there, with K equals 0, 1, 2, 3, 4, 5, my time, it becomes here 0, 1, 2, 3. My file name is K plus 1, which flips over to here, 1, 2, 3, as K goes up. My spectral intensity is J plus 2, and you'll understand that J plus 2 brings me to here, and here, and here. And the spectrum color will be my headers, X above here, red, green, blue, value. Nothing special here. I'm setting an image area, location where the images are located. And I'm also going to be writing the sky2.csv file. I'm going to read the sky.csv file, and I'm going to write to the imaging area sky2.csv. So here's my write file, imaging area, as I said. And here's my line list. I'm using CSV Reader. I'm opening up the CSV file. It's a new line is a space, and the delimiter is the commas. For the row in the line list, I start the process, range 0 to 6. I'm reading the classification I. Row is rows 0. Then I'm going to print the classification I just to see what it does. I print two things. I print the title or the headers, and you'll see, as you can see here, this is why I have classification 0, which is time, classification 1, which is the file name, value, and spectrum. I do that because I don't need a red, green, blue, and gray. They're all going to be going into here. And I'm going to define what the spectrum color is. Here I'm printing for information the same stuff. I'm also printing K, N, X, I, and J because I needed to do some calculations. So here I am using N, and if you recall, N is the row being processed. I is the total number of rows being processed. I minus 6 divided by 6 plus 1. I'll get more detail to why that is the case later in this episode. I set x equals 0, k equals n times 6, n plus 1, and j plus 2. So what I do is, while x is less than 4, so 0, 1, 2, and 3, I am printing the time, the file name, the spectral value, and the color, red, green, blue. I'm also writing this out just for information. And I add 1 to x and 1 to j while I'm going through this process. Once I finish this process, I'm going to indicate that the images were processed successfully. And then I close the file. So let's run it and see what it does. I'm going to right click and say run read files. There we go. It's done. Extremely fast. It's completed without any errors, and I have some data here. Let's go up and see what it did. The first thing it did was it printed out these 0.jpg, 415, G00416.jpg, 2134, and with this value here. But as you can see, what it's doing is the first line in the dictionary is the file name in this particular case, followed by the red, green, blue, and color. Then I get time, file name, red, green, blue, value. And it keeps on going up and up and up all over the place. It's bouncing all over the place. It's not in any particular order. So how do I read that? So what I had to do is I had to look at the time, the file name, value, spectrum. So 3041, that is the time. That is, the file name is G03042.jpg. And I have the color red with the value, color green with the value, color blue with the value, and the gray value is the sum of the three above. As you can see, for me to do this, I needed to ensure that the time and the file name were identical for the first four values. When it's done, I did the same thing for 3004. You see 1, 2, 3, 4. This is what it looks like. So again, I've taken the values that were along each column and I placed them all into one column, ensuring that I got something like this. So what does that look like from a print perspective? Well, let's find out. from the looking at the file from a file perspective, we can see that we had a sky CSV. So if I go to pictures, dust, here's my files. As you can see, I got this JPG and MP4, so it didn't get processed. There's my skies. So what did this look like? Here's all my files. So if I look at sky, and I'm going to open it with the text editor, you see that I have time, file name, red, green, blue, value. That was from spicy.py. And this is what I have. This type of a file configuration makes it easy for me to look at each color individually in R and not be affected by having to create if statements and everything else. But what if I wanted to put the red, green, blue, and value, the grayscale, all onto one graph with different colors? Well, to do that, I'm allowed to do that by using this read file that I wrote, and this is what I end up with. I end up with the time, the file name, the value, the spectrum. So time 3041 G03042.jpg has a value of 49.43, and it's red. 49.43 green 50, blue 149.610 value, the grayscale. And then I continue down the process. So to recap, what I did was I taken a file that I generated that has multiple columns in it, and I then taken the header information, put it in its own columns, redefined and put in under its own columns, and I've taken the column spectral information and put it all in one column. That is this. Well, I hope you enjoyed this little video on how to manipulate files in Python, and that you'll be able to use this information to create your own types of file manipulation. Again, there's lots to learn about dictionaries, tuples, lists, arrays, and just for your information, if a tuple or a list just doesn't seem to work for you, 80 to 90% of the time, the dictionary will. Thank you for watching, and have a wonderful day.